Okay, so welcome everyone to the 2020 AMATIC webinar series, Tools for Building Big Data Career Pathways at Community Colleges. We have several panelists today: Joyce Mallon-Smith, Paul Hansford, Michael Harris, Sarah McGillivray, James Polzin, and Suzanne Smith. This is sponsored by a joint statistics committee of AMATIC and ASA, as well as the AMATIC Data Science Subcommittee. The views expressed by the presenters are not necessarily the views of AMATIC, and commercial products mentioned are not endorsed by AMATIC. McGraw-Hill is the sponsor of the 2020 AMATIC webinar series. And I will stop sharing and let Sarah share hers. And while she's doing that, to get started, the panelists have said they will take questions at the end, respond to questions at the end of the webinar. But if you do have questions during the webinar, feel free to type them in the chat, and they will prepare some answers for you by the end. And with that, I will turn it over to Sarah and the rest of the team.
Great, thank you so much, Patrick. I wanted to thank Patrick and also Julie, who helped coordinate this for us, our hosts of AMATIC and the ASA Joint Statistics Committee and the AMATIC Data Science Subcommittee. As Pat mentioned, my name is Sarah McGillivray, and I am the project manager for this project, Mentoring New Data Pathways. And this project is part of Education Development Center's Oceans of Data Institute. So today we're going to hear from presentations from my colleagues. First, we will hear from Joyce Mallon-Smith, who is with me at Education Development Center in Waltham, Massachusetts. Suzanne Smith joins us from Johnson Community College in Overland Park, Kansas. James Polzin with Normandale Community College in Bloomington, Minnesota. Michael Harris from Bunker Hill Community College in Boston, Massachusetts. And Paul Hansford with Sinclair Community College in Dayton, Ohio. Each presenter is going to introduce themselves, share some information about their data science programs, and then share the tools that they use to develop these programs. Just a bit of background for you. So the tools that we're going to talk about today are the products of a partnership between EDC's Oceans of Data Institute and Bunker Hill Community College, Johnson County, Normandale, and Sinclair. These products are the product of two projects that were funded through the National Science Foundation's Advanced Technological Education, or ATE program. So in the first project, the colleges developed data programs at their own institutions that was creating pathways to big data careers. And then in the second project, we are engaging with mentee colleges, and the partner colleges are serving as mentors as they guide a new set of colleges through the process of creating a data pathway. So there is, of course, a great deal of interest in data pathway development, and recognizing this, we developed 3 tiers of support as shown here as part of the project. So our presenters today are working with a cohort of 6 mentee colleges, and they're assisting these institutions in the development of their own data pathway, as I had said. So that's sort of our first tier. Our team is also convening an online community of practice that's designed to engage as many colleges as possible in our project work, and letting them interact with the tools that we've developed. So the community of practice is going to be sharing experiences through online facilitated discussions, webinars, and other activities. And then finally, the third tier is the project network, which will communicate updates and resources from our project as they're released, and the materials will be posted and made available for download from EDC's Oceans of Data website. So this is just a quick glimpse at what we are calling the data pathway development process. This is what sort of a framework that we're using to guide our work, and this is the process that our mentee colleges are currently participating in with mentor institutions. So the tools that you see here marked with an asterisk are the ones that are going to be spoken about today. And then the full 6-point process and each of the tools below will be shared with the community of practice through a series of webinars held later this fall. So what are the tools? I'm going to turn things over now to my colleague Joyce Mallon-Smith.
Hi, I'm Joyce Mallon-Smith, and I lead a body of work at EDC exploring how people develop skill and knowledge in and out of school and then translate that into a productive and rewarding career. Through this work, we've developed this suite of tools, resources, and processes to identify what expert work looks like in both traditional and emerging occupations, and align curriculum with local industries' expectations for worker proficiency. Many of my recent projects have focused on data science and computer science. And over the past 5 years through ATE funding, we've been working with community colleges to develop pathways in data careers. And through that process, we've adapted this suite of tools to develop robust data programs tightly aligned with industry expectations for proficient data workers in the 4 communities represented by these colleges. I'm just going to go quickly through some of these tools and introduce them to you. After that, the colleges will talk a bit about how they've been using some of the tools to help them build their programs. Colleges use the building blocks template to inventory existing and planned programs, certificates, degrees, and supportive activities that can be used to develop a data pathway. On this tool, faculty list the titles of any 2-year or 1-year programs and certificate programs that are in place or being planned. They list courses and course numbers, number of credits, prerequisites necessary for enrollment, the job titles that this program prepares graduates for, and the names of companies and contact information for employers actively supportive of the program. This tool provides a landscape view of what's already in place across the college and what might be planned to build on existing programs and courses. Let's take a look at the profile. The profile of the data practitioner identifies what middle-skilled data workers, often found on data teams, what they do as they perform routine tasks and solve problems that arise on the job. It was developed by middle-skilled workers considered by their colleagues to be experts in their field, and it was validated nationally with other currently employed data practitioners. They defined the work of the middle-skilled data practitioner in this way. The data practitioner, in service of an organization and/or stakeholders, supports the data lifecycle by collecting, transforming, and analyzing data, and communicating results in order to inform and guide decision-making. The profile describes a universe of 64 tasks that would be performed by middle-skilled data practitioners. No one person is likely to be responsible for all of these tasks. However, when used for curriculum development, it describes what might be included in a well-developed, robust curriculum leading to data careers. One of the strengths of the profile is its specificity in using verbs. Tasks include, for example, determines data structure, merges data, creates new data, performs data mining, articulates conclusions, conducts causality testing. The use of these verbs are key to developing curriculum that reflects what successful middle-skilled data workers are expected to be able to do when they perform successfully on the job. Let's take a look at rubrics. Rubrics, working with a subgroup of data practitioner expert panel, the project developed rubrics that can be used as either teaching tools or assessment guidelines. These performance-based rubrics provide examples of what data practitioner work tasks look like in practice in the workplace. Level 3 of the rubrics define what employers identify as their expectations for the proficient data practitioner. And you can see as we move along these rubrics that examples of what data actually looks like in work based on an entry-level beginning worker who might communicate understanding of a problem to the proficient worker who would propose a type of analytic process needed to solve the problem. Level 3 in this rubric tells you what employers think a proficient data worker should be able to do. Let's take a look at the gap analysis tool. The gap analysis tool helps employers prioritize the work tasks of middle-skilled data practitioners and helps colleges align their curricula to specific employer priorities. Employers review the profile and rate each task according to whether their frontline middle-skilled data practitioners need to be familiar with the task, perform the task under supervision, or perform the task independently and lead others in performing that task. College partners also review the profile against their curricula to determine if students are expected to know the task in their curricula, if their curricula tells them or helps them learn to practice the task, or to master that task. College and employer scores are then analyzed to determine the gap. And depending on the outcome, colleges add or remove tasks from their curricula and/or adjust the performance level outcome to match employer expectations. Once the gap analysis is determined, then the curriculum analysis is conducted. The curriculum analysis matrix helps colleges identify where each task is taught within their programs and the performance level expected in various courses. If adding tasks to the curricula, it helps determine where in the program course sequence a specific topic or task should be included. This tool also helps colleges review tasks and performance levels to identify and create strong task-based learning progressions. And a stackable credential model. The stackable credential model helps colleges, college partners, and students visualize the entry and exit points of the pathway to data careers at that college. As a model, it helps colleges explain how their data degree program, certificate program, or workforce development micro courses or credentials fit into their larger data workforce development strategy. This and other tools have been used by colleges around the country to help plan, implement, start, and then strengthen their data programs that are leading towards jobs as middle skilled data workers. I'm going to pass it along now to Suzanne, who will start talking a little bit about how she's used some of these tools in the development of her program, and then she'll pass it along to some other of our college partners so they can share their experiences with you also. So take it away, Suzanne.
Okay, hello there. My name is Suzanne Smith. I teach at Johnson County Community College, and that's in Overland Park, Kansas, and that is a suburb of Kansas City. So we are in a metropolitan area. So as a result of working on this grant, we came up with a data analytics certificate, which basically can be done within 1 year. And some students, many students do that. Other students, we had figured that a lot of students maybe would be working and not be able to go to school full time. So some people take longer than that. But for the first semester, we have these first 4 classes that they usually take: Introduction to Data Science, and then Data Visualization, SQL for Data Analytics, and then statistical programming, Introduction to Statistical Programming. And then for semester 2, they take the statistics course that's already in the mathematics department. So they'll take that. Now, none of these are in stone as far as which semester to take them. So some people have already had statistics. Some people take them the first semester. Then we have a data mining course, an intro to machine learning course, and then a big data architecture course. So throughout all of those courses, the students are introduced to Python, Tableau, Hadoop, SQL, and then we throw in some KNIME. I use KNIME sometimes in some of my courses, just as kind of an overview. It's kind of maybe some of you are familiar with it. It's kind of a visual representation. You don't have to write any code for it, but it's really good for introducing the data cycle to students. And then we throw a little bit of Excel in there too. So we have a wide variety of backgrounds that our students come from. Many of them already have bachelor's degrees. Some of them have master's degrees. And some of them are actually working on data in their current jobs and just want to learn these new skills to be able to stay in their current jobs. And then, of course, there's other students who don't know anything about working with data when they come in. After our program, we've had students go on to graduate level programs if they already have had a bachelor's degree. We've had that happen. Sometimes they are able to find an entry-level data analytics job, and then some of them just go ahead and use those skills that they've learned in their current job. We have 15 students, usually. That's just an average of students each year that are working on the program. So we have quite a few students in the program who are, and it's definitely very in demand. We usually fill up our classes fairly well. Okay, so one of the tools that we used was this profile of the data practitioner. I had taught actually in mathematics departments for many years before going into the computer science department. And so I had taught a lot of statistics, but I'd also worked with data a lot as a software analyst, but really didn't know anything about this new field of big data. And so I really had a lot to learn. And so this profile was really great because it helped me and those others who were developing the curriculum for this program to know what was needed, what the students needed to learn in order to be successful in a data and analytics job of today. And I thought it was really interesting. One of our top students last year came to me as he was graduating and said that he had recently met a data scientist from the Dallas area and just kind of met him as a friend of a friend. And as they were talking, this data scientist had quizzed him over, did you learn this topic? Did you learn this topic? Basically went through a list of all of the different topics that this person thought was very important for someone to learn with a data analytics certificate. And it was the student was able to say he was very happy to say that he had been, everything had been covered. So he felt like he got a very good introduction and very good education to data analytics. So that was really great, and that was one of the tools that we used.
Great, thank you so much, Suzanne. So this is Sarah. I'm just going to move things along and hand it over to James Polzin from Normandale. He's going to talk about the gap analysis tool.
James, before you start, can we
Sure.
jump in and do a couple of polls and find out a little bit of information about people who are attending the webinar today? So if we can jump in with a couple of polls, that would be terrific. So Sarah, you'll have to stop sharing your screen. Oh, there we go. So all of you out there can see the polls on your screen. If you would take a moment and let us know what your responses are. Pat, you want to let us know when polling time is finished?
Yeah, I'll give them a few more seconds. Joyce, did you get that other question that I sent you?
Yes, and I posted it on the on the.
Okay, I see that. Thank you.
Yeah.
Okay, we'll let it go a few more seconds. We got about 75% of the people have voted. Okay, looks like we're holding still. So here are the results.
Oh, interesting. So the red indicates the highest number. Is that how this is working? Good. Do we have one other question? We may as well put that up now as well. It looks like a number of the participants have also been implementing a data program. So I hope we have an opportunity for people to chime in and answer some of the questions in the chat. Don't feel as though we as presenters are the only people who can answer the questions. Jump in and have an exchange in the chat box while we're continuing our presentation. So the second question, how would you best like to receive support? We're all very busy. We want to make sure that any kind of services are offered to those. We don't want to waste our time trying to offer some services that are not useful. So if you could let us know what kinds of ways you prefer to receive support, that would be very helpful. And then Pat, let us know when we're done with that. And if any of you have any comments on any of the questions in the polls, please also direct those comments and questions to the chat box. And thank you. So as we move ahead, we would like to make sure we invite all of you, not only those who are planning and thinking about a program, but those of you who have experience, to join our community of practice next year as we move it forward and conduct webinars and have dialogues online to share with each other our experiences in developing programs. So thank you all, and let's go back to James.
Good morning. I'm Jim Paulzine. I'm from Normandale Community College in Bloomington, Minnesota. We're in a large metropolitan area. We're a suburb that's just south of the Minneapolis-St. Paul Twin Cities in the state of Minnesota. Our kind of major focus as a community college is the first 2 years of 4-year degree programs. We have a lot of transfer students that come through. We also are able to provide Associate of Science degrees in various areas. We have a very strong math, computer science background. My background is computer science, and fortunately for us, our computer science program is housed in the math department, and that was very convenient as we developed this data analytics program, because it's very much math and computer oriented, as we all know. Our focus was to develop this transferable 2-year degree to a 4-year institution, and it was a little bit of a struggle because there were not a lot of 4-year degrees available at the time for us to transfer to, but we were able to make that happen. One of the things that we used was this gap analysis tool, and it turns out that that has all kinds of benefits tied into it. The obvious ones are it gives us an opportunity to work with industry to figure out what types of skills they would prioritize for students coming out of a 2-year program. And we convened a meeting of industry professionals from the area. We had them look at the data practitioner profile, which was very, very helpful because it formed a common language. Lots of different businesses have specific terminology that they use for parts of the data work cycle, and the data practitioner profile gave us a common language where we could look at a foundational set of terms that people would have to translate to their particular environment, but they were able to work together then and realize, oh, we're really talking about the same thing. And then as an institution, we were able to take this same tool and come back and look at our curriculum and decide, so how are we providing these different skills? We know what industry would like to see. What are we able to produce within our curriculum, or what are we already producing within our curriculum that matches up with the expectations of industry? And then we were able to add new courses, slightly alter curriculum to match more closely to what industry desired in certain areas. And so it was a very valuable tool cutting both ways. In addition, the most amazing thing to me was the peripheral benefits of working with industry. It was very, very helpful to have industry come on campus and provide their input through this gap analysis process for 2 reasons. One, it made them feel vested in the process. They knew that they had a need for workers, and they knew that they were providing input. An interesting side benefit was the fact that they met with other industry professionals and got the perspective of what these people were interested in. And I think that interaction within the industry working towards supporting education really strengthened their desire to help out with the curriculum. They knew that they weren't the only ones, and they knew that they were providing input so that they would be able to have an impact on the curriculum. And I think that spurred their interest and made them more committed to the process. Also, as an institution, we were able to show them what we were doing, and it wasn't just us coming to them and saying, we have this program and here's what we're providing, you should use it. With this gap analysis tool, they were saying, these are the things that you're going to need to provide. And we were listening and we were incorporating those things. So this was very helpful in establishing that relationship between academia and industry, between industries, so that they knew they could work together and support a program like ours, and that they would be getting students that potentially could help them with their work. One of the other interesting side things that came up, if you could pop up that degree program description, Sarah, there were certain requirements we had to meet in the state of Minnesota to have an Associate of Science degree. And at the very bottom here, we have a list of what we would call domain specialization areas. This was something that was presented to us from industry where they said, you know, it's great if people can do some statistics and math, but it's really critical that they have some understanding of the business environment they're going to work in. And they called that the domain specialization area. Are you going to be in finance? Are you going to be in law enforcement? Are you going to be in the insurance business? You should have some understanding of that business model. And one of my colleagues at Normandale, Peggy Rado, did a very strategic, careful job of going through the general ed requirements and selecting courses that would match for particular areas. Like, for example, at the top of the list there, you see bioinformatics. Well, it's very important that a person who wants to go into that has some foundational biology knowledge and some chemistry knowledge. And so we selected general ed requirements that would, in addition, give them some experience in a particular work or business area so that they would be more marketable to that area that they wanted to work on. And that's pretty much it.
All right, thanks so much. We are going to move things forward again and hear from Michael Harris at Bunker Hill Community College.
Hi, everyone. I'm Michael Harris from Bunker Hill. I've been a full-time faculty at Bunker Hill since 2014, and we've developed a data analytics associate's degree. I'll kind of go through a little bit about Bunker Hill and a little bit about the degree program we developed, and then I'm going to go through the curriculum analysis matrix. It's a tool that we use similar to what James and Suzanne talked about where we're going through these tools. It's a tool we use in order to better solidify the program when we're designing it. So kind of a little bit about Bunker Hill. It's a suburb, it's inside Boston, or it's in Charlestown, which is about a 5-minute walk from Boston Garden. It's a very unique school in terms we have student body, which consists of 25% demographics across the board. So it's 25% Caucasian, 25% African American, 25% Hispanic, and 25% Asian and other. So it's pretty unique in terms of we have a very wide range of student body in the student population. So it's a great environment to teach it. You have people from all walks of life there. We also have a very large international student population. So out of the students, we have over 600 international students. Interesting to see what happens now after the ICE ruling yesterday. We've been going through emails because we have a very large international student population, which is up in the air right now. But anyways, let me go through my data analytics degree. And what we did is we broke the degree down and passed it through curriculum committee in a bunch of different levels. So we use what's called the stackable credential model. So we have a couple different certificates and they stack into a degree. And I believe Paul's going to be talking about the stackable credential model coming up. But our focus was we wanted to focus on 3 different languages. So we focus on R, Python, and SQL. So for each one of those languages, students take at least 2 semesters of each language. But the first certificate that we developed this in 2015, was the data management certificate. And the data management certificate consists of 5 courses. It's 16 credits. So the first course is an introduction to data science with R, a statistics course, a problem solving course, a data visualization course, and SQL. The data viz course we use Tableau. So the idea when we first developed the data management certificate was for people in industry that are looking to understand data better. So a lot of times people that have a bachelor's or a master's degree, but they don't have the ability to understand how to deal with databases or how to write queries on SQL, how to import data into R, how to visualize them. So that's what that certificate was initially focused towards. From there, we stepped up to the data analytics certificate. And in the data analytics certificate, we have a 2nd level of R, a 1st level of Python, a 2nd level of SQL, and a course in Linux. The course in R, the 2nd level course in R, that's a machine learning course. So it's data analytics and predictive analysis. In that course, we start teaching some machine learning algorithms. The Python's an introduction to Python. The SQL is the second version of SQL or PLSQL. And then we have a Linux course. James mentioned a lot about ties to industry. One of the things that we found out when we were having our meetings with industry is they wanted to have Linux in there. Excuse me. We met with three different companies when we were setting up the course, and each one of the companies wanted to have Linux in there, basically because the people are going to be setting up databases, running them on Linux servers. So we have that in there as well. Then finally, we have our Data Analytics Associates degree, and the Data Analytics Associates degree added another layer of Python, calculus, and linear algebra. So for our entire program, it's between 62 and 66 credits. The difference being if somebody needs to take pre-calculus or if they test into calculus. If they test into calculus, they don't need to take pre-calc, and it's a 62 credit certificate. They don't test into calculus, they have to take pre-calc, it's a 66 credit certificate. So there is a lot of credits there, and it is a decent certificate. One of the things we're working on right now is setting up the articulation agreements for the four-year colleges. So for our current student body, I'd say about half of the students that I have inside my Intro to Data Science and Data Analytics courses already have bachelor's and master's degrees. A number of them are looking to go into master's degrees in data science, and they're taking some of the courses just to make sure they, A, like the field, B, as kind of an introduction before they jump full head into the field. Last semester, we had a student go into the University of Chicago. One went to NC State, one went to NYU. So they went into three really good courses coming right from the program, but they all actually had their bachelor's degrees. The program is set up though for students to come out of the program and to go directly into a job in the field as well. So we've had pretty good success with people having direct hires in the field. In the next slide. So one of the tools that we used was this curriculum analysis matrix. And we used this for specifically two different reasons. One of them was used it for curriculum committee. And one of the things for curriculum committee is they want to know, as we're organizing the course, how everything was put together, where our learning outcomes are coming from, how we designed it, how we designed everything out. So the curriculum analysis matrix, if you look at the left-hand side, you see the heading items. Those are the heading items from the data practitioner profile. The next column, it says desired level. Now, the desired level comes from, if you run through the data practitioner profile, kind of what we did is we used that data practitioner profile. After we developed it, we looked at people from industry, and they rated how important the skill sets were, and we came up with a number value. So that number value is what corresponds to the desired level. So for example, if we have a desired level of an 8 or a 10, that's something that students are going to have mastery of. So what we want to do is we wanted to make sure that we are covering all those in all of the courses. So this is kind of a quick introduction to, there's 3 courses if you look on the right-hand side of the screen. Intro to Data Science, Data Analytics, Intro to SQL. And then there's a letter corresponding to introduction, if they're introduced to the topic. P is proficient, if they're proficient with the topic. M is mastery, if they've mastered the topic. And the idea is all of the higher numbers will have a mastery level in one of the courses at least. So for example, collects data. By the time the students finish the data analytics course, they're going to be expected to master that, master the collecting data. So this curriculum analysis matrix, as I said, it was used not only for curriculum committee, but it was also used for our learning outcomes. So what we did is we developed specific learning outcomes for the high numbers in the desired level. So for example, collects data, that turned into a learning outcome in the program. The other thing it did is it helped organize the topics in each course, as well as a general progression of knowledge across courses in the program. And what that means is it leads us into what course goes where in the program. So we want to make sure that we have the introductions and the proficients before we have the mastery levels. So when we're setting up the certificates and we're setting up the final associate's degree, we want to make sure there's a nice even flow towards the program itself.
Excellent. Thank you so much, Michael. So we are now going to move once more. This is our last presentation, last but not least. We're going to move things over to Paul Hansford from Sinclair Community College, who is going to talk us through the stackable credential model.
Hi, everybody. I'm Paul Hansford. I'm a full-time faculty and a member of the CSIT department at Sinclair Community College, and I love it. I've been teaching on the college level for since 2014, with about 20 years of experience. I'm the point person for the academic data analytics programs at Sinclair, not to be confused with our institutional reporting and analytics for our whole community college. I'm involved in several grants for the National Science Foundation and supply chain, mentoring big data pathways, and enhancing IT. A little bit about Sinclair. We are in the middle of Dayton, Ohio, a nice metropolitan in the Midwest, and we've been serving the Dayton community for 134 years. We have over 300 accredited programs to choose from, and we service about 32,000 students annually from around the world. Our CSIT data programs, we offer 9 programs, which are associate degrees. One of them is up on the screen right now, and 14 certificates. Our data offerings include a 1-year certificate, which has been in place for quite a while, and an associate's degree, which is what we were launched as a part of the grant that we were with for creating big data pathways, and a short-term certificate. Our data programs and certs offer core courses in CSIT for IT fundamentals, math and stats, which you would expect, and then gen ed courses, depending if it's a degree or a certificate. Our data-related courses are advanced Excel for analytics, various database courses, think SQL, programming with Python, data viz with tools like Tableau, Power BI, and then advanced theories courses for like various data science subjects. We offer a strong emphasis on internships, thanks to our work-based learning department, and service quite a few students in IT. They typically come at us similar to Mike. About 80% are traditional students that are looking to retool. Most of them already have their bachelor's degree. It is split between male and female, about 50-50, which is very unusual for CS-related programs. So about the stackable credentials report. Our colleges met in May of 2018 in Normandale Community College, and we began working on the 12-page report for the stackable credentials. At Sinclair, we call them embedded credentials, but it means the same thing. Doing this work, I recognized the need for creating a short-term certificate, and the idea for this is to create various entry-level pathways to get students involved in related roles to make it easier for them to complete the various degrees or certificates. In other words, there's courses there that will lead them into those higher levels. A lot of the students, surprisingly, even with their bachelor's degree, will jump into some of these courses, especially if they have low prerequisites, and will complete those short-term certificates and or associate's degrees to kind of freshen up their skills so that they feel confident to jump into those master's programs or maybe even those PhD programs. 2 things that were really important to Sinclair was to enable the courses with little to no prerequisites if we can, to help people that were looking to retool or refresh their skills. And secondly, to create those pathways, bridging the gap on the front end from high school to college, and then on the back end from the 2-year to the 4-year articulations. We started with the 1-year certificate in place. That was prior to me. And we created the new degree as a part of the grant. I think I mentioned that before. What's next? And then we, as a part of that stackable credential, that embedded certificate, we created a short-term certificate called Data Fundamentals. And we're looking to add an advanced kind of Excel series that would be basically a series of SQL courses on various subjects to compete with some of those online offerings that are out there, and MOOCs and boot camps and things like that, which will probably mean that we'll put that in place hopefully by next fall. I think that is it for my part. I wanted to mention that the strategy for creating embedded certificates or stackable credentials is really designed for people at different levels. You can see that the certificates are at various credit levels, 15 credit levels, 27, all the way up to 60, to the 4-year degrees. So people can move in and out of those internships, work-based opportunities, as well as picking up the industry certifications that they need with some of the courses. Some courses are aligned directly to certifications. In some of the programs, you would have to take more than one course to align to a certification. I talked kind of fast there, Sarah, but I think that is it.
That's perfectly fine. You included a whole lot of really great information in a very short amount of time, so that's awesome. So I'm going to open it up to the questions that we've received in the chat, but before we do so, I think I will turn it over to Joyce, who had a couple of thoughts she wanted to share.
Yes, thank you. I just wanted to, as we were going through this presentation and talking about the program, I wanted to draw attention to one thing that actually attracted us to doing this work to begin with, and that's the starting place for all of this support. Many programs are looking at developing education programs by starting with what it is that students need to learn. And this whole initiative really begins in a different place. It starts with, what do expert workers need to know and be able to do? And based upon that work, the work of identifying what are the industry skill standards for the middle skilled data worker, which are defined in the work we did to define the profile, you'll see that all of the tools are based on what was developed in that profile that was developed and validated by expert middle skilled data practitioners. So I just wanted to bring that to your attention, that the starting place and the work, that all of this work is grounded in industry skill standards, which really focus on what it is that successful workers need to know and be able to do. And that's the comment I wanted to make. Thank you.
That's
Shall we
great.
go on to questions? Thanks.
Yeah, thank you, Joyce. This just came through, and since Paul just spoke, Paul, I know you entered into the chat, but could you differentiate between the level 3A and 3B associates? And I can go back to the slide.
Sure. I think that the difference would be with in particular, the 3A is really designed to articulate to a 4-year program. And the differences will be there in the type of math that is required to do that, depending on your location, depending on your state requirements and things like that. Calculus seems to be kind of the gateway course that makes the difference for that, depending on the institution, the state rules and things of that nature.
Great, thank you. All right, so going back a bit, we had quite a bit of interest in which industries were consulted in each of your each of your conversations. So I know a couple people popped answers in the chat, but I wondered if people could talk a little bit about the different industries and areas.
Sure.
Yeah, I can go.
I had
Oh, go
sent
ahead.
out the link to Mini Analytics in the Twin Cities area, and that's a gigantic industry users group that was started by several data analytics professionals. And so in the Twin Cities area, we had representatives from the medical industry, from large financial institutions, medical device companies, manufacturing, and insurance industry. And we tapped into Mini Analytics, and of course they had access to thousands of people, so we had a pretty broad spectrum up here.
That's great. Mike, did you have something to add?
Yeah, the industries we tapped, so initially we met with the government, so the state of Massachusetts. They're about 5 minutes away, so we met with their data science team. We also met with people from Biogen, because there's a strong biomed presence in the Boston area. And we also met people from Tufts University. So we wanted to get someone from industry, someone from education, someone from government. So kind of tapping the brains of kind of someone from each one of those groups.
That's great. That actually, colleges, please interrupt me if I'm cutting anybody off, but that actually segues really nicely into there was quite a bit of interest between community college and university partnership. So specifically asking about examples of community college and university partnerships that have created seamless programs of study for students to allow them to complete a 4-year degree, and then as part of that, what sort of barriers you encountered in trying to develop that sort of partnership.
I can probably speak to that. This is transferability to 4-year institutions, is that correct?
Yeah.
Yeah, so there's several barriers there. One of them is to find specific 4-year degree programs that are related to data analytics or data science. There are a lot of graduate level, masters and above, in terms of data science, where they're looking for the brilliant, forward-thinking, theoretical people who can try new things to get more information out of data. The 4-year programs are just starting to show up. And it is a struggle. It's a struggle to find a match. And then in addition, besides trying to fill your curriculum with things that could be helpful, especially if you're looking at a 2-year degree leading to a 4-year degree, now you have to match the transfer requirements. So as far as going to a 4-year, I think probably the biggest barrier is to find a partner school, a school that is going to be able to work with you to create a seamless transition from a 2-year program to a 4-year program. And those are just kind of up and coming. And somebody might want to make a comment on that that's out there across the US here, of the 4-year programs that they're aware of, because I think that's still a fairly small number.
Suzanne, I think you had also entered something into the chat about partnering.
Well, actually, not for us. We at the time I was looking around at that, we didn't have, as he was just saying, we did not have any schools in the area that were offering a bachelor's degree in data science. We had master's degrees, but I couldn't find a 4-year school to go to. I think some have come up now, and we just haven't pursued that lately. Yeah, I think I was talking about a couple of the other issues when I answered
okay.
that. So.
My mistake, sorry. Paul, did you want to add anything? I know you're typing into the chat as well, but. Okay. All right. I'm sorry, I'm having trouble seeing and answering questions and reading things. So a question about, I believe this was about prerequisites. So for first level certificates with statistics, do stats courses have college algebra prerequisite? And if so, is that a challenge for industry students?
Yes, I have always, I have always thought that would be a challenge, as having taught in the math department. for many years. I know what a struggle getting through all of those algebra classes are for so many people. And so we do have the statistics as one of our courses. And so since it's the regular statistics taught in the math department, it does require college algebra first. So my concern immediately was that might limit some people getting through. We haven't heard from that. I don't know. It seems like most students who are good students seem to be getting through that without any problem. I haven't heard anyone talk about the difficulty of that, but I could imagine that would be limiting some people.
Any other colleges want to comment on that question?
Well, in terms of the math requirements, I'll just chime in that's a difficult thing. You know, we're in kind of difficult times right now. Math is kind of like a dirty word, right? I mean, people are trying to avoid math at all costs. So that's another difficult balance, is how do you pack a good curriculum into 2 years? How do you get good math training, especially when students are coming in deficient to begin with? So college algebra is almost a bare minimum requirement, and anything above that is certainly icing on the cake.
I also see that as a challenge for like trying to attract high school students into the programs. It seems like that the students that are, maybe they have some sort of STEM background in like chemistry or biology or technology, are making that, jump a little bit better than the traditional students that maybe don't have strong math skills, which they should, but we're not seeing that.
So I'm gonna switch tracks just a little bit. We had a bunch of questions about the credentials that are needed for faculty to be able to teach these courses. Who can teach them? Do the different accreditation bodies have similar requirements? Oh, sorry, that's a different question. Hang on. So let's focus on the credentials needed for faculty.
Yeah, so once again, go ahead, Susan.
Oh, okay, sorry. Yeah, we had decided to, this is taught in the computer science department. So our other courses require, computer science master's degree, but we changed it a little bit for our data analytics courses to allow a mathematics degree or data science degree or computer science. And if they don't have a master's degree, they can, if they have enough of those higher level credits, they can also get by if they have some good industry experience. So HLC is our accrediting body, and they seem to be fine with that.
That's great. Jim, did you have something to add there?
I was reading through the chats and I lost my train of thought. Sorry.
Oh, that's okay. So the second part of the question about finding faculty. Oh, I'm sorry. So the question was, what was the process in finding faculty who could teach the data analytics courses, and are there pre-quals to be able to teach the courses? And I apologize if that's already been answered.
Well, I will. I'm sorry.
Here we go again. Suzanne and I are jumping in on top of each other.
No, you go first.
Okay, it's difficult to find instructors, and I don't think, again, if there's not four-year degree programs and anybody getting a master's or a PhD, it's going to be really hard to find. We're looking at people who have a degree in a related area, like computer science or mathematics or statistics, that has some expertise in some of the areas like R or Python and skills in that area. In fact, at Normandale, we do have an adjunct instructor who has a master's degree in statistics and knows and works in the analytics field. So we're fortunate to have someone who can come in and teach those courses. But there won't be a credential probably in the near term. If you find someone who has a degree in data analytics or data science, that'll be great. But if not, you just need somebody who's got expertise in that area.
Yeah. And I just read this question and then my train of thought left on that too. What was that last question that we were answering? Sorry.
About the credentials for instructors.
Yeah.
Oh, yeah. Yeah. Okay, I'm sorry. I do see this question, so I'll go ahead and answer this. It says, yes, so you're right. Oh, now I remember the previous question. So anyway, yes, masters in mathematics for sure would not necessarily, the teachers would not have the knowledge necessarily needed. So yes, we would definitely make sure that they have that knowledge through work or other courses that they've taken. We actually had no problem finding adjuncts to teach our courses. So, when we started, we had these eight new classes at the time. Now we only have 7 plus statistics, but at the time we added 8 new data analytics courses altogether. And I had, had some statistics and had worked with data. So I was able to jump in and, teach a couple of the courses, but we were able to advertise for adjuncts. And because we live in a metropolitan area, we were able to get people from different, really nice, great places. We actually got a guy who worked, had a master's and PhD. One was from Stanford, one was from Harvard, and but he came to the Kansas City area because he wanted to live, he grew up there. So anyway, we were fortunate to find these because yes, we would have not had near enough people who really knew what they were talking about in our department at full-time instructors yet. So
yeah, I'll just add one more thing. Adjunct faculty, as Suzanne just said, adjunct faculty, that really isn't a problem. One of the good things about data science is, especially at least in the metropolitan areas, there's a lot of jobs with data science, and a lot of people inside the field have the idea of they want to give back to the community. So there's a lot of people that work inside data science that jump at the chance to take an adjunct position. The harder part is finding full-time faculty. So how do you convince somebody that can go out and make $130,000 a year that a $40,000 a year job is very rewarding? So the full-time faculty is a lot harder to do. At Bunker Hill, our requirement's a master's degree. It has to be in a STEM field. It does not have to be in data science. So if you have a master's in mathematics, a master's in engineering, in another STEM field, you then have to get the knowledge to teach the courses, but you can be hired as a full-time faculty for it. But the difficult things, full-time faculty, adjuncts, we really don't have a problem with.
I was going to kind of echo the same things. When we have our industry meetings, we do them annually in Ohio for our degrees as a part of our accreditation. Most of the data scientists around the area that come to these meetings are just anxious to help in any way, shape that they can. It could be job shadowing, it could be mentoring, it could be teaching courses and things like that. For full-time faculty, we've had some faculty jump into master's programs and others that just are super excited about the various languages like Python or R, and they're excited about it, so they love teaching it. So
so I don't want to stop anyone from talking, but I do realize that we're getting very close to the end of the hour. And in case people do have to leave, I just wanted to pull up where they can find the tools and resources that were discussed today. And we can definitely go back to the discussion. I just wanted to make sure that I shared this, and I'll put the link in the chat as well. If anyone has if any participants have any questions, also please feel free to go ahead and add those into the chat.
Talking about finding faculty, unfortunately, we have a little bit of a bias. I think every one of the people on the panelists here, the community colleges, are all in large metropolitan areas and big industrial hubs. I was totally oblivious to how big of a industrial and commercial area the Kansas City area was until I went down there and saw all the people that they were helping out and all the different industries that were present. And Massachusetts and Dayton, Ohio, big industrial hubs. But I think anywhere you go in industry, there's going to be people that are involved with data analytics, and there may not be a huge supply, but you'll probably find a few people who may be able to come in and give you some advice and be willing to commit some time to teaching the one-off or the 2 or 3 courses during the year that could be helpful. So hold on to that hope. Hopefully you'll be able to connect with somebody. And I also noticed several comments in the chat about people offering their courses online. So I'm hoping that there'll be some synergy there where the community colleges can reach across and share some of those courses across institutions.
Sarah, I'm going to jump in real quick. As you said, it is 11 o'clock, and if people want to stay and ask more questions, that's fine if the panelists are willing to stay. But for those that need to leave, let me just jump in and wrap things up officially. And then Sarah, you can reshare yours.
Sure.
Thank you all for attending. If you would, by way of the chat, please give our panelists kudos and tell them a job well done. This is very informative, and they, with 6 panelists, they really flowed well together and played off each other well. This is very impressive. If you're not a member of AMATIC, we'd love to have you join. We do have a presence on Facebook at AMATIC if you are interested in using that. We do have some upcoming professional development options. The conference, as of right now, for Spokane is still in the works, as far as I understand. 2021 in Phoenix, as well as webinars, more webinars coming up and traveling workshops. The recording, the chat, and the PowerPoint will be available fairly soon after this. It will be posted on AMATIC and also sent out to those who register and attend. And here is the QR code and the link to evaluate the webinar. And so I can let Sarah pull her slides back up. I will put the link to the evaluation in the chat message. For those that want a certificate of attendance, there is a question in the evaluation where you can request a certificate. So I will let you all get back to your discussion, but I just wanted to thank Joyce and Suzanne and Sarah and Michael and Paul and James and Julie for helping coordinate this. Thank you for your attendance. Let us know if you have any questions. And Sarah, I'll turn it back to you for more comments and questions if there are any.
Thank you so much. This has been a really great experience for our team to present. So I just wanted to put up the slide inviting everyone to join the community of practice that we have hosted online at the Oceans of Data Institute website. So I popped that link in the chat as well as a link to a couple of the other tools. And again, we're going to be doing a fall series of webinars, beginning in fall, to go through more of the tools in the entire development process that I showed at the beginning of the webinar. So I'm going to put up a thank you slide just because it has our contact information on it, and take a moment to thank everyone at AMATIC for at AMATIC for hosting, and thank all of the participants for your great questions and thoughts that you've entered into the chat today. So this is our contact information. Feel free to reach out at any time. And with that, I will just go back to the chat and see what other questions we might have had. All right, I'm not seeing any additional questions, so I'll just say thank you. And again, we will make all of the tools available on the Oceans of Data website. And Pat, I assume that they'll be contacted to let them know when our slides are posted?
Yes, Sarah, so whenever we finish, if you could send me the PowerPoint, I will download the recording, upload it to YouTube, send it to George to post on the website, and then I'll send that as well as the chat transcript to everyone here, and let you know when it's posted, and then you can share it with whoever you want to.
Great. All right, so on behalf of our project, thank you so much. This has been really lovely.
Thank you, team.
Thank
Thank you
you.
all. This is very well done. I enjoyed
All
working
right.
with you. Thank
Thank
you all.
you, everyone.
I'm going to stop the recording.